how do we get, if you will, depolarized? How does a stimulus trigger depolarization? So that's kind of where we are right now, right? We got a stimulus. This can be anything, right? This can be chemicals, this can be light, this can be pressure, this can be stretching, it can be anything. But we know now that these electrical signals here, right, all involve some kind of potential change that we've got to talk about. So this receptor needs to transduce the stimulus, right? Transduce means to just convert, right? It has to convert whatever the signal is out here to an electrical signal. And these receptors, the first electrical signals that they generate are these things called graded potentials. So these graded potentials are often AKA, also known as, oftentimes, what we call receptor potentials. Not always, but a receptor potential is that. Now the word graded means what? What do you think? If you see the word graded, what do you think a graded response means?
It has a certain mark of...
It can't have a mark. Does the mark always have to be constant? No, a graded response means that the response can vary based upon something, right? So these aren't constant responses. In fact, these responses could be obviously depolarizing, right? So it could be depolarizing. But these responses could even be hyperpolarizing. Okay, now let's think about a hyperpolarizing potential for a second. Is there any way that a hyperpolarizing potential could reach threshold? Because it's what? If you're minus 70 and you get a hyperpolarizing potential, what's the value of the neuron going to be? Minus 80, minus 85, minus 90. That's further away from threshold. So, what's the significance of these? What do you think the significance of that is? What do they prevent?
Crisis?
Well, just in this flow here, what do they prevent? They prevent action potentials. Right? So, would you call that, if something prevented something, would you call it inhibitory or excitatory?
Inhibitory,
right? So these hyperpolarizing things here are inhibitory. Now, again, stopping the flow of information sometimes is just as important as enhancing the flow of information, right? Inhibiting signals moving in your brain and in your body is sometimes just as important as causing them to happen, right? Any type of central nervous system depression, I don't mean depression in kind of a psychological sense, I mean just a lowering of electrical activity in your brain is all about inhibitory responses. Parasympathetic responses, would you expect them to be excitatory or inhibitory? Mostly inhibitory. So sometimes it's important to prevent the flow of information. On the other hand, if we had a depolarizing potential right here, would you expect that to be inhibitory, or what would be the opposite of to inhibit? Enhance or allow, we call it actually excitatory. So these graded potentials here, that's what we're working on, these things that are graded, vary by the strength of the stimulus. And they can either be depolarizing and potentially trigger an action potential, or they could be hyperpolarizing and inhibit the action. You okay with that? Now, let's see what we have here.